Hello, very good afternoon to all. Right. So I'm Vivek, and today we are going to discuss our paper. That is the paper that was held on 21st of May. So today we are going to discuss the solution and important questions and important concept of this question paper. Right. So let's start with the today's session. That what type of question that we are going to study. I hope you all write your exam well. Okay. So let's discuss the paper. So yeah, we are going to discuss all the two papers, that is paper one and paper two. So starting with the paper one. So this is the first question in paper one, right? Okay. So according to this question, what the question asks basically, I hope my voice and is audible to all of you, and my screen is also visible. If you face any problem, you can just text me, right? So that we'll sort out this problem. Okay. So according to this question, that is the two gases in a joining vessel are brought into contact by opening a stopcock between them. The one vessel measured 0.25 liter and contained nano at 1200 torr and 220 Kelvin. So the condition is given, that is nothing but the volume and the temperature. All these things already given, right? Now, for the other measurement, the volume is this and contained O2. So at 900 torr and this much of temperature. The reaction to form N2O4 is exhaust the limiting reactant completely, neglecting the vapor pressure of N2O4. The pressure of the gas remaining in torr is 223 Kelvin. After completion of the reaction is P. So you have to calculate the P by 50, right? So you have to calculate the value of P here. Okay, so let me discuss this question. So we know the reaction. Let me first write the reaction. That is when the 2NO react with O2, it will gives us 2NO2 plus N2O4 plus N2O4. So what is the initial mole of NO? So the initial mole of NO. So the initial moles of NO is nothing, but it is equal to, it is already given, that is 1200 pressure into 0.25 volume, and this is the 716, and this is R, and this is 22. How will you get this? We know that PV is equal to nRT. So we can calculate from this, that is N is nothing but is equal to PV upon RT. Okay, so this is what. So we know that in this question, P is already given, that is pressure is 1200 torr and the volume is 0.25. R and T we already written as this one, right? So this is all about, this is how we do convert this torr into this. So it will divide it by 760. So this is number of moles here, right? Okay. So N is equal to PV upon RT. So from there you can just write as 1200 into 0.25 into 760 into R into 220. So this is all about the initial mole of NO. So this is how you can calculate the initial mole of NO. Similar on the similar way, just calculate the initial moles of O2. So how will you calculate the initial mole of O2? So we can calculate as this is nothing but 900 into 0.15. The condition in the second way the pressure is given 900, right? Okay, and again divided by 760 just to convert this torr into pressure unit, right? And this is R and this is 220. So it will becomes out to be nothing but 125 into 760 into R into 220. Now, from these two equation, you can identify which one is the limiting reactant. Right here, in number of moles of, if I'm considering the number of moles of NO and number of moles of O2, so we know that number of moles of O2 is less than the number of moles of NO. So we can say that here O2 is the limiting reactant. So O2 is limiting reactant, right? So O2 is limiting reactant. So first thing we find that in NO and O2, O2 is limiting reactant. So everything will depend on O2 only. Okay, so by this we calculate the number of moles, and just by knowing the number of moles, we get to know that is O2 is a limiting reactant. Okay, chalo. So O2 is a limiting reactant. Now, what is the moles of NO remaining after this reaction? So the moles of NO, right? The moles of NO remaining after the reaction. Remaining after the reaction. Clear? Hai? So the moles of NO remaining after the reaction is nothing but it is equal to 300 minus 2 into 135, and this will be divided by 760 into R into 220, which is equal to nothing but 270, 300. That is 30. 760 into R into 220. Okay. So this is how will you calculate this. So you know the number of mole. Then how will you calculate the pressure? So pressure of remaining NO gas. Pressure of remaining NO gas. Remaining NO gas. So we know the number of mole of remaining gas. What is the number of mole? This is equal to nothing but 30. That is 760 into R into 220. So this is N. What is P? P is equal to nRT upon V. Right. So we can calculate as this is nothing but just multiply this thing that by 760 P into 220 divided by 760 into R into 220 we already have. Just put the values, right? So I'm putting the value, that is 220 into 0.40. R is already cancelled, so it will become 760 into 220, and this is nothing but P. So 760 into P into 220 into 0.40. So this will comes out to be 75 torr. 75 torr. So this is the pressure. So what is in this question they are asking P by 15. So what is P by 15? This is nothing but 75 upon 15, or we say it comes out to be 5. So what is the correct answer for this question? That is 5. So what is the value of P by 15 is P by 15 value is nothing but 5. Right? So I hope you understand this question, how this question will solve. Right? Okay. Now, the second question is very important one. This is from the basically colligative properties. So the question is, a solution is prepared by dissolving 10 gram of non-volatile solute in 180 gram of H2O. If the relative lowering of the vapor pressure is 0.05 and the molecular weight of the solute x into 10 into 2, what is the value of the x? So we know that for the relative lowering in vapor pressure, what the formula you know? We know that, let me solve here. We know that according to the relative lowering in vapor pressure, the formula is like P naught minus Ps upon P naught is equal to mole fraction of the solute, right? Mole fraction of the solute, which is equal to number of mole of solute plus number of mole of solute plus number of moles. So this formula we already know. This is entirely known as relative lowering in vapor pressure. So this value is already here, which is equal to 0.005, right? Now you have to calculate this N and capital N on. So let's calculate this and put the value in equation 1, you get the answer. So let calculate the small n first. For the small n, that is the mass of the solute upon the molar mass. So a solution prepared is 10 gram of non-volatile solute, that is 10 gram of non-volatile solute in 180 gram of the solvent. So we want you have to calculate the molecular mass of this. So this is nothing but x, right? This is nothing but x. So this value can't know. Now, capital N notice, this is mass of the solvent is 180 and the molar mass of H2 is also 18. So it will comes out to be 10. So this value comes out to be 10. Now just put the value here. That is 0.05. And what is then here? That is 10 plus x. This is 10 plus x. plus 10. Right. So on solving, how will you get? You'll get like 0.005, and this is nothing but 10 by x, and this is the LCM is x. This is 10 plus 10x. Right? This is a 10 plus 10x. So on solving, what you'll get? You'll get like, let me calculate here. That is 0.005, which is equal to 10 over x into x over 10 plus 10x. So you cancel out this, right? So what you left with, that is nothing but 0.005 into 10 plus 0.005 into 10x, right? And it is equal to nothing but 10. So on solving, if you take the common 10 here, so what you'll get? You'll get like 0.005 plus 0.005 x is equal to 1. So you can calculate x from it, right? So what is the value of x comes out to be? It's nothing but x comes out to be 199. Right, so x comes out to be 199. So this is the correct answer. So this is a simple question. We can say state-based question from the relative loading and vapor pressure. So we will say that this is a very simple question, right? So this is all about question number 23. Now let's see about the question number 23. We already discussed about the question number 22 completed. Now what is question number 23? So according to this question, in this question, what they ask basically. So in question number 23, a KMnO4 oxidized to Xn plus ion to XO3, right? Xn ion to XO3, itself changing to Mn plus 2 an acidic solution, 2.6 required 1.6 K4MnO4. Find the value of N if the weight of 1 gram of equivalent of HCl is 84. The atomic mass of X is A into 10 into B. What is the value of A plus B upon N? Right. So you have to calculate this value. Right. Now let's see how will you calculate. So we know that MnO4, that is MnO4 negative. This will react with X N plus and H plus in acidic medium. So it will gives us Mn plus 2 XO3 and nothing but water. So what is the N factor of MnO4 here? So here Mn, the oxidation state is plus 7. Here the oxidation state is 2. So what is the N factor of Mn? Nothing but 5. Right. So the N factor of MnO4, right? So the N factor of MnO4 negative is nothing but it is equal to 5. So this is the N factor of MnO4 negative. Similarly, what is the N factor of this? This Xn plus, this will convert it into this. So this will nothing but, this is Xn plus 1 and this will be converted into XO3 negative. So here the oxidation state is plus 5 and here the oxidation state is 1. So 1, 2 plus 5, right? 2, 3 is 6, 6 minus 1, that is 5. Okay, so this will be 5. So what is the N factor of NO4? 5. What is the N factor of Xn plus, right? N factor of Xn plus is nothing but 5 minus N, right? 5 minus N simple. Okay, so this is nothing but 5 minus N. Okay, now we know from the law of equivalence, that is the equivalence of MnO4 become equal to equivalence of Xn plus, है ना? So the equivalent of MnO4 plus is equal to equivalent of Xn plus. So we can write as 1.61 into 10 की power minus 3 into 5, which is equal to 2.68 into 10 ki power minus 3 into number of moles, that is 5 minus 1. Okay. So from here we can calculate n, which comes out to be 2. From here we will get n, which is equal to 2. Now the equivalent weight of HCl2 is already given. So equivalent weight of HCl2 is already given, that is 84. Right. So what is the molar mass of this? We know that equivalent weight is molar mass upon 2. So molar mass is equal to 84 into 2. It's a factor, that is Valence factor, right? So we can calculate this, that is 84 into 2, which is, comes out to be 168 gram per mole. This is nothing but 168 gram per mole. Now, what is the atomic mass? Atomic mass of X. So what is the atomic mass of X, beta? It is nothing but 168 minus 71. है ना? Because XCl2, na? So 168 minus total molecular mass comes out to 161. So the atomic mass of X is 161 minus 72, because chlorine Ca2 having 72. So it is comes out to be 97. 97 means what? That is 9 into 10 plus 7. So we can say that here A is nothing but 9, B is nothing but 7. Right. So this is 90 plus 7. A into 10 plus B. So A is 90 and B is 7. And N we already calculated. So what the answer, that is A plus B upon N. So A plus B, that is 9 plus 7 divided by 2, which is equal to 8. Right. So this is 8. So 8 is the correct answer for this question. Right. I hope this is clear to you. In this question, we first of we have to calculate this. That is the n factor. So according to equivalent mass, this n comes out to be 2. Right. Because in this question, KMnO for oxidize Xn plus I into XO3, itself changing to Mn plus 2 in acidic solution. 2.6 into 10 per mole of Xn plus require 1.61 into 3 mole of 4MnO4 negative, right? 4MnO4 negative. So this will already require. Okay. Now find the value of N. So we calculate N here. Now if the weight of the 1 gram of equivalent of X is equal to 84, the atomic mass of X is. Right? Okay. So from this you can solve this. Now cover 22, 23. Now let's move to the next question number 23. Just give me 2 minutes. Then we'll start this question number 23, right? So just try to solve this question till. Right? So let's discuss question number 24, right? So the internal energy change in the conversion of 1 mole of calcite from calcium carbonate, right? From the calcium carbonate to the argonite form is this, right? So this is already given. Okay. Calculate the enthalpy change when the pressure is 1 bar, given that the density of the solids are this. That is 2.71 gram per centimeter cube and 2.93 gram per centimeter cube respectively. Express your answer as delta H upon 35 in joule per mole, right? So you have to calculate this. Okay, so the internal energy change in the conversion of 1 mole of calcite from calcium carbonate. So let me write as calcite when they are converted into aragonite, right? When the calcite is converted into aragonite, 1 mole of each, right? So the 1 mole of calcite converted into the 1 mole of aragonite. So when this will takes place, the internal energy change is given. Now for this delta U is given positively 0.21 kilojoule, right? Okay. So we can convert into joule as well. It comes out to be 210 joule per mole. Then delta H, we know what is delta H. It is nothing but it is equal to delta U plus delta P. Okay. P is given 1 bar. Now just calculate delta H. How will you calculate delta U is given 2110 plus how will you calculate delta P into V? So P is 1 bar. So we can write as P. And how will you calculate V? So V in terms of density, we can calculate like it is nothing but mass upon density. So we can calculate the volume, that is PD2 upon V1, right? Here we can writing as PV delta PV as P and V2 minus V1. So V2 corresponding we can write M upon D2 minus M upon D1. And this is into 100. Why you use 100 beta? Because we know that 1 liter bar is equal to 100 joule. So if you want to add, we need the same units. Like if delta U is in joule, then this will also be in joule, right? So 1 liter bar is equal to 100 joules. So we can write as, right? Now, this is nothing but equal to 2110. P is already given, that is 1, or we say 100. And this is total mass is given in this question. Calculate the enthalpy change with per given that the density of the solid is 271 gram per centimeter cube. So it is already given, that is a 271 gram per centimeter cube. So we can write as this is nothing but 100, right? That is 100. And this density is given like 2.93 10 raised to the power 3 minus 100 271 into 10 raised to the power 3. So this is how will you write this. So what the answer comes out to be? So on solving, you'll get the answer like delta H is nothing, but it comes out to be 2110 minus 0.277, or we say it comes out to be 209.72, right? In this value, what they want, they ask delta H by 35. So it comes out to be 6, right? So delta H by 35, it comes out to be 6. So this is all. So this question is from basically thermodynamics. So the internal energy change in conversion of 1 mole of calcite from calcium carbonate to the aragonite form is 0.21 kilojoule. Calculate the enthalpy change when the pressure is 1 bar, given that the density of the solids are this and this respectively. Express your answer as a delta H. So we are in this question, first we convert delta U, that is kilojoule, into joule. And we know the formula delta G H is equal to delta U plus P delta V. P is given, that is 1 bar. So we can convert 1 bar into 1 liter as 100 joule. Okay. And delta V is equal to nothing but molar mass upon density minus m upon d1 into 100. So we can write as 210 into 100 upon this. So we'll get the value like this. Okay. So this is a very simple question. Move to question number 35. What the question number 35 asks? According to this question, a drop of solution 0.05 ml containing 6 into 10 to the power minus 7 mole of H plus. If the rate constant of the disappearance of H plus is 6 into 10 to the power minus 5 mole per liter second, it takes X into 10 to the power minus 10 second for H plus in the drop to disappear. What is the value of X? So the drop of the solution having this volume contains 0. Mole of H plus. If the rate constant of disappearance of H plus is this, so it takes X into 10 to the power minus 8 second for H into drop disappear. What is the value of X? You need to calculate this, right? Okay, so now it is a zero order reaction already given, I guess, right? From the unit of rate constant, we know that this is a zero order reaction. So it is zero order reaction. Okay, so it is a zero order reaction. Now, what is the concentration of H plus ion in a drop? That is the concentration of H plus ion in a drop. Okay, so concentration of H plus ion in a drop is nothing. It is equal to 6 into 10 to the power minus 7 divided by 0.5 into 10 to the power minus 3. So it comes out to be 1.2 into 10 to the power minus 2. How is it come? That is already given. That is the drop of solution of 0.05 volume, right? Drop of 0.0 contain this much mole of H plus ion. So we know that concentration is what? Concentration is nothing, but that is equal to number of mole per unit volume. That is N upon V is equal to concentration. So here the number of mole is already given. That is number of mole 6 into 10 to the power 7. So 6 into 10 to the power 7 divided by the volume, that is 0.05 ml. So we get the concentration of H plus ion. Now, if the rate constant of disappearance of H plus is 6 into 10 to the power 5 mole. So here the rate constant is given. Rate constant K is given. So what is the rate constant here? So the rate constant is nothing but 6 into 10 raised to the power 5. That is mole per liter second inverse. Right. So this is already rate constant is given. Now you need to calculate the time. So what is the time of disappearance? Time is nothing but that is equal to concentration into rate constant, because we know that what is the formula of rate of reaction, that is equal to dx over dt. Right. So if you want to calculate the dt, you must divide the dx upon r. Okay. So dx is the concentration and r is the also. Right. So how will you calculate this? Rate constant is given. So what is t? So T is nothing but this concentration, the which comes out to be 1.2 into 10 to the power minus 2 and divided by the rate constant, that is 6.0 into 10 to the power 5. Right. So when you calculate, you'll get the answer like 2 into 10 to the power minus 8 second. Okay. So this is equal to x into 10 to the power minus 8 second. So what is the value of x? It is nothing but 2. Right. So it takes x into 10 to the power second. So 2 into 10 to the power second, right? So this is also a very simple question. So first, by looking at the unit of the rate constant, we get to know the order of the reaction. It is the zero order reaction. Now H plus concentration of H plus ion in a drop, we can calculate by number of moles upon volume. Now rate constant is also given, so we can calculate T. T is nothing but rate constant upon Sorry, that is a concentration upon the rate constant. So this is how we can calculate. I hope this is clear to you, right? Because for the zero order, we know that this is T is equal to nothing but R naught minus R upon K. So this is the T. Okay. So this is the T. So we know the concentration, that is the concentration of H plus ion, and just dividing by the rate constant, we can calculate this. Okay. The next question is, how many dichloro products are obtained in the following reaction, including stereoisomer? So you have to calculate how many dichloro products. So you have to calculate the number of dichloro products that are formed in the following reaction, including stereoisomers, that is this and this. Okay. So let's see how many of these are formed. Basically, what happened when the okay. So when this treated with Cl2 in presence of some sunlight, they will produce? They will produce nothing but okay. Here on chloro, one chloro. Again, this also possibility like dichloro products. Now, so this is one possibility. This is another possibility. Uh, this one, this one. Okay, this one. And the another other possibility is like here chlorine and here chlorine. One more possibility. One more possibility is like one more possibility is like good. No, so only two possibility, right? The next possibility we like this way. Oh wait, this thing, this thing, this. Either you write this or write this one. So this one. Let me write the name of each so that you can understand the differentiation between these two. The first name is 1,2-dichloro. 1,2-dichloro compound. So it is a cis isomer and it is an enantiomer pair, right? This is a cis isomer. This is also known as 1,3-dichloro. 1,3-dichloro, and this is nothing but 1,1-dichloro. So how many possibilities are there? That is three, right? So how many dichloro products are formed in the following reaction, including stereomedicine? So the dichloro substituted products are like this only. So the total is seven. The total possibility is seven. That is 1, 2, 3, 4, 5, 6. 2 to 4, 5, 6, 7. So total is seven possibilities. Right. Now, in the next question, they are asking, this is given and react with CH3NO to NaOH. A is the major product. If M is the molecular mass of A, find the sum of digit of M. So you have to find the digit of sum of M. So how will you calculate this? So whenever we know that whenever this CH3NO2 plus OH, right? So it will produce nothing but like this one is taking place. Okay, so this will O. Let's react with CH3NO2. Right. So this will take place with CH3NO2 plus NaOH. React with NaOH. Okay, this will react with NaOH and heat it. So what the product they will form? They form the product like this. Okay, so this is A. This is A. So as the molecular mass of A is nothing but 141. So sum of the digit, that is 1 plus 4 plus 1 is equal to 6, right? So this is 6. So 6 is a correct answer for this question, right? Okay, now next move to the next question, that is question number 29. So let me fix some water, then after we're going to discuss this question number 29 as well. Okay, so the colloidal solution can be purified. So which option, by which way you can purify the colloidal solution, Meta? So the actual is dialysis, electrodialysis, and ultrafiltration. So this is the three methods, that A, B, and D. That is the dialysis, electrodialysis, or ultrafiltration. We can purify colloidal solution, right? So this is simple question, more than one option type. Now, question number 30. What the question number 30 asks? A 2-liter vessel contains 4 moles of N2O5. On heating to 100 degrees Celsius, N2O5 undergo complete dissociation to NO2, NO2. Mark out the correct interference if rate constant for the decomposition of N2O5 is this. Right. So if the rate constant, that is K, is given. So if the K is given, that is nothing but 6.2 into 10 raised to the power minus 4 second. Okay, second inverse. You have to mark out the correct inference, right? First, the half-life N2O5 is 117 seconds and is independent of temperature. The first option is whether it is true or wrong. So it is absolutely wrong, because we know that for the half Osler is nothing but 6.2 upon 0.693. So it won't come out to be 117 seconds, right? So this is absolutely correct. Wrong. Next, the molar ratio of the reacted mixture before and after 40% dissociation of N2O5 is 5:7. And the third option is the time required to dissociate 40% of N2O5 is this second. Use log this. Now, if the volume of the container is double, the rate of decomposition will become half of its initial rate. So let's see the. We need to solve this question in order to get the correct answer, right? So let's solve this question so that we can get the correct answer. So what is this? This is question number nothing but 30. Okay. So according to this question, decomposition of N2O5, how it take place? So N2O5 decompose into NO2 plus O2. Let me write the complete valence equation to 4 again, right? So this is what. Now initial concentration at T is equal to 0 when the reaction does not start it. Then the initial concentration of N2O5 is 2 molar and its concentration is 0. When the reaction started, yeah, it means at T is equal to something T, right? Then this will become 2 into given 1 minus 0.40, which is equal to 1.6. And this concentration is nothing but already given. It's given now 0.42, 0.40, because alpha is given 40%. Now, so what is K? K we know 6.2 into 10 to the power minus 4. So what is T half? T half is nothing but 0.693 upon K, which is equal to 6.2 to the power minus 14. This comes out to be 117.7 seconds. Right? 1100 17.7 seconds. So initial modes of reaction of mixer. So I hope you understand this thing. This will come out to 11.117. So the time required is 40% into 5 is this much of second. So whether it is come or not, yes, definitely. So the number of moles, so the number of moles, right? So the number of moles, yeah. So the number of moles of reaction mix. So the number of moles of reaction mix or number of moles of reaction mix after 40% dissociation. After 40% dissociation. So the ratio of the number of mole mix upon my total number of mole mix after 40% dissociation is nothing but equal to 2 upon 3.2, which is equal to 5 by 8, right? Which is equal to 5 by 8. So what is T comes out to be? T is nothing but 2.303 upon 6.2 into 10 to the power minus 4 log 10 by 6, or it comes out to be 824.6 seconds. So this statement is absolutely correct, right? So statement C and D is absolutely correct, right? Okay. The next question is, that is question number 31. What the question asks basically? In this question, they are asking aqueous solution of potassium propanate is electrolyte. Possible organic products are. So when the aqueous solution of potassium propanoate means CH3, CH2, this, right? So this is CH3, CH2, and COOK. So when they are electrolyzed, we'll get N-butane, this one, this, and ethene. So all four products are possible. That is A, B, C, and D. So all these four products are possible. Okay. Now, next question number 32. What the question number 32 asks basically? So then this, you have to identify the correct one, that is NaOH. When this is treated with the NaOH in presence of ClCH2, COCl. So what will form? So that is, one is this and another is this. So these two, that is only A and C will be formed. Now, which of the following statement are correct? In many alpha and beta decay process, gamma radiation is emitted, right? And the nuclear isomer produced by the alpha ray bombardment have the same atomic mass and number but different in their lifetime. Gamma radiation is very penetrating relative to alpha and beta particle. Alpha nuclei in an excited state may lose its excitation energy and return to the ground state by the emission of the electromagnetic radiation. So which one is the correct? That is both. That is both in the sense all of the options are correct. That is A, B, C, and D. All these four options are correct. Right? Now, this question is again from the colligative properties. That is question number 34. So which of the following statement is correct about the given aqueous solution? 0.1 molar KCl solution will have the same osmotic pressure as 0.1 molar glucose solution. So this is absolutely wrong because we know that in KCl we have a two ion. So this is absolutely wrong, right? So explain the following which are incorrect. So this one is incorrect. Next, 0.1 molar of KCl solution of the great same boiling point is 0.1. This is also wrong. So this is also 0.1 molar glucose and 0.1 molar isotonic. Yeah, this is true, right? So this is true. Now the 0.1 mole of MgC into solution have the least relative lowering of vapor pressure 0.1 mole of NaCl. This is also true, right? So the correct option is that is A, B, and D. Okay, so A, B, and D are the incorrect option. Now, move to the question number 35. What the question number 35 asks? Which of the following compound are the more acidic than ethanol? So you have to identify the more ethanol. We know that out of alcohol and phenol is more acidic than ethanol. So B is definitely the correct one, right? Now, here, due to presence of electron withdrawing group, they are also more acidic. They are also more acidic, and this one. So, since this is a no, hmm. So, ethanol, aromatic acid, so ethanol is weaker than this. So, the correct option is A, B, C, and D. Right? So, which of the following compound is the most acidic than phenol? We can write this. Now, which of the following statement is are correct? So, you have to identify the correct statement. LiH, NaH, KH, RB, serial thermal stability. So, it is you have to identify the which statement is correct. So, this statement is absolutely correct. This is about the thermal stability. KO2 is a parametric nature. This is also correct. So, the statement this is 37. B is also correct. C, milk of magnesia uses the antabase. No, milk of magnesia cannot be used as an antabase. Antacid. They act as an antacid. BCl2 is a polymeric structure in the solid state. This is also true. So which of the following is true? That is A, B, and D. Right? So A, B, and D are the correct option. What could be the structure of the compound A if neither dissolve in NaCO3 nor give a characteristic color with FeCl3? So what color of the structure of the compound A? Yes, you have to give the answer for this question. What is that is A, right? CH2OH. That is the compound A is neither phenol nor color with the FeCl3 has a carboxyl functional group, does not dissolve in aqueous system, right? So this is the correct. Now, this is a match type of question and very important. So in column one, we have a complex or ligand name, and column two, we have a magnetic field pair. So double salt. So if I'm talking about the double salt, so FeSO4, that is a Mohr salt. So this is an example of double salt. And A is equivalent to T. So A is equivalent to T. T, we have a two options, that is B and C. So A is equivalent to T. It is clear. So 18. Next, that is Ziga salt, EDTA. So bidentate, monodentate, hexadentate. So we know that EDTA is a hexadentate. So A is equal to T and D is equal to Q. So D is equal to Q, D is equal to Q. Yeah, so option B is correct. Because A is equal to T and D is equal to Q. These two we know that hexadentate ligand is nothing but EDT. Now, what is this PT glide 2? So here B is equal to P. So Jessa salt is equal to this one, Jessa salt. That is nothing but KPTCl3C2H4 and BS. B is also equal to S. Jessa salt is equal to diamagnetic. C is equal to R. PTCl C is equal to R. That is a bidentate. And C is equal to S. C is equal to S much means C is also equal to S. Right? PT glide 2 is also time. Okay. So I hope this is clear to you. How this type of question you'll solve. Okay. Just take a 2-minute break and then we'll discuss more question on this. Right? Okay. So we covered all the important questions of this paper one. Right now, let's discuss paper two. So you already covered paper 1 all question. In this, we are going to solve a paper 2 question. Now, for the first order reaction, the rate constant is given. Calculate the time in second required for the initial concentration. 1.2 mole reactant to reduce to this. So this is simple, I guess. We know that for the first order, what formula we use, that is nothing but T is equal to nothing but 2.303 divided by K log R naught upon. So here 2.30 remains same. Rate constant is given. Yeah. That is 7.67. 10 raised to the power minus 2 log. What is R naught? R naught. R naught is the initial concentration. Initial concentration is 1.20. This is 0.7. So just solve this, you'll get the answer. Nothing else. So in solving, you'll get the answer like 6 seconds. Right. So correct answer is 6 seconds. Now, next question is also very important. 22. Question asks, how many lone pair of electron on an atoms in a melamine are involved in the resonance? So first of all, let me draw the structure of melamine. Right. So let me draw the structure of melamine like. Right. So this is the structure of melamine, that is NH2, NH2, NH2. So in this question, they are asking how many of nitrogen are involved in the resonance. So there are 3 lone pair of electron are involved in the resonance like this, this, this. So the total number is 3. So 3 number of nitrogen participate in the resonance. So this is a diagram of melamine. A hydrocarbon acts as a molecular weight of 80 gram per mole. 12 gram of magnesium at 12 gram milligram of sulfur react with the 1.08 ml of H2O to 0 degrees Celsius 90 of pressure. Ozone listens of X gives SCHO and CHO, CH2 only. What are the total mole of SCHO and CHO produced by the 1 mole of X? Right. So you have to identify this. Now we know that mole of X right? So this is the mole of X, which is equal to 12 into 10 over 3 upon 80, which comes out to be in a similar way, the moles of H2 22,400. So it comes out to be nothing but 4.5 into 10 to the power minus 4, right? So it comes out to be 4.5 into 10 to the power minus 4. So we can say that this acts as a 3 double bond, like CH2. Right? So this is all about the total number of moles that we'll get. So it comes out to be n is equal to 3. So how many of the following compound give positive Fehling solution test? Phenyl, NaOH, and OH, right? So basically, in this question, the compound other than salicylaldehyde and pentane 2,1 give positive Fehling sign. So except salicylaldehyde, this one, and pentane 2 on this one. Rest all give Ferring solution test. Always remember this, except these two, that is salialdehyde and pentane 2-one. Salialdehyde and pentane 2-one all give positive Ferring solution test, right? Okay, so this is all about now. In question number 25, what they are asking about when the 0.742 gram of mixture of aluminum and its oxide were reacted with the solution of sodium hydroxide, that is 840 ml of a gas, was evolved. Measured in standard condition, the percentage of aluminum oxide in the initial mixture. So you have to calculate the percentage of the aluminum oxide, right? So how will you calculate this? Percentage of the aluminum oxide. Okay, so let's see how will you calculate. We know that mass of the mixture of aluminum and Al2O3 is already given. So let me write as, yeah, mass of aluminum and Al2O3. It is already given that 0.743 or we say 42 gram, right? Now, we know that what happened when the aluminum react with NaOH, 2Al react with 2NaOH. It will provide 2Na ALO2, right? So it will provide 2Na ALO2 plus 3H2. Okay, so it will provide 2Na ALO2 plus 3H2. Now, this Al2O3 react with 2NaOH. So it will give 2Na ALO2 plus H2, right? So when the Al2O3 react with the 2NaOH, it will give 2Na ALO2 plus H2, right? Now volume of H2 gas at STP is nothing but 840 ml, right? So the number of moles of H2 the number of moles of H2 is nothing but 840 divided by 22,400. You'll get 0.0375. Similarly, number of moles of Al is nothing but 2 by 3 into 0.0375. 10. So it comes out to be 0.024. Okay. So now what you need to calculate? You need to calculate the percentage of aluminum oxide in the initial mixture. So the percentage of aluminum oxide is, first step you have to calculate the mass of aluminum oxide. So mass of aluminum oxide is nothing but 0.025 into 27, or it comes out to be 0.675 gram. Okay. Similarly, the percentage of Al2O3 in mixture, percentage of Al2O3 in mixture is nothing but 0.742 minus 0.675 divided by 0.742. So it comes out to be 9%, right? So it comes out to be 9%. Clear है सबको? Now, how many of the following carbohydrates on treatment with the access of phenyl hydrogen give the same osazone, like glucose and this following? So always remember, glucose, mannose, and fructose give the same osazone with the access of phenyl hydrogen. Glucose, mannose, and fructose. So glucose, mannose, and fructose. So only these three will give. So the correct answer for this question is 3. Correct answer for this question is 2. And the correct answer for 25 is this 9%. Right? So this is very good question. Okay, so which of the following is are true? So the A is V1 upon V2 is equal to T2 upon T1 is equal to 3 by 2 for the reversible adiabatic process, right? For the reversible adiabatic process. So is it true? This is question number 29, I guess, right? Yeah. So for an ideal monoatomic gases, when the y is equal to 5 by 3, adiabatic equation of the expansion, we know that adiabatic equation is nothing but T1 V1 gamma minus 1 T2 V2 gamma minus 1. So V1 upon V2 comes out to be T2 upon T1 की power 3 by 2. This is absolutely correct. So this is the correct one. The next is at low pressure Z is equal to 1 minus A upon VRT. This is also correct about the compressibility factor. Now, the next is a gas can be liquefied below its critical temperature. Obvious, it will be liquefied below its critical temperature at a high pressure, and higher the value of a weaker is the this is lower the value of A and weaker in the intermolecular force. So the correct option is A, B, C. So A, B, and C, these three are the correct. Now, question 30. That is, salt of which of the following radical will give brown fumes when treated with concentration H2SO4? So obviously that is NO3, right? That is NO3 because NO3 salts and the Br negative. So these three, NO3 and the Br negative. So salt of which of the following radical will give brown fume when treated with H2SO4? That is Br negative and NO3. Now, 31 question. The coagulation of salt may be brought about by heating, addition of Sol opposite charge, this is correct. Adding electrolyte, this is also correct. Persistence dialysis. So what is the correct answer of this? That is all of the four options. That is A, B, C, D. So all A, B, C, and D, all these four options are correct, right? So the coagulation of Sol may be brought about by heating, adding Sol of opposite charge, adding electrolyte, and persistence dialysis. So these all four are the correct options, right? Now, the coagulation of a sol may be brought about by, yeah, we already covered this question below, right? Yeah, that is A, C, B, D, all are correct. Now, question number 32. So let's move to the question number 32. That is, which of the following elimination reaction will give but1-ene as the major product? So which of the following reaction will give but1-ene as a major product? So we have option like A, B, C, and D. So just observe carefully. That is option B and C. Because we in this we have a 3 degree of methyl group is there. Here also 3 degree of methyl group is there. So we know that 3 degree will give the major product as compared to the second degree and the first degree. So B and C, this will give a major product, right? Okay, move to the next question. That is question number 33. So point out the incorrect product. So you have to point out the incorrect products. So when this will treated magnesium ether, this will form this OH and this will not happening. So out of this A, B, and D, that is A, B, and D, these three are the incorrect. So this is the only correct product of this question, right? So these three are the incorrect. Now, the compound given below is more acidic than S3N, YQH, and S3. Which they are more acidic than which? The compound given below is more acidic than. So that is A, more acidic than carboxylic acid, B, and C, right? So this is more acidic than alcoholic group, ethyne group, and carboxylic acid, right? So sulfonic acid is a stronger acid than carboxylic acid group. So that's why, except sulfonic, that is A, B, and C, both are correct answer, right? Now, let's move to the question number 35. That is the correct statement regarding a colloidal solution is R. So what are the correct statement regarding a colloidal solution? So the correct statement regarding the colloidal solution are the Hardy-Squeeze rule deals with the coagulating power of an electrolyte. So this is very much correct, right? This is very much correct. Brownian movement and Tyndall effect are the properties of colloidal state. Correct. Gel is a liquid dispersed in the another liquid. So no, gel is a liquid dispersed in the solid. So this is wrong. Now gold number deals with the protective power of lyophilic. This is also correct. So which of the following is correct in question number 35? So A, B, and D. So A, B, and D. So these three statements are absolutely correct. Now lactose on hydrolysis. We all know that whenever the lactose in hydrolysis, right? Whenever the lactose is a hydrolysis, it will give glucose plus galactose. Right. So look, lactose or hydrolysis give glucose and lactose. So both A and C is the correct answer. Okay. Now, so this is the statement types of question. So in this question, the considering the equation calcium sulfate dot 2H2 plus calcium sulfate dot 1H2 plus 3 by 2H2. So here the compound is given. This one, and this. Then the HF means enthalpy of formation is also given. That is this and this. Delta H is in kilojoule and transformation of 1 kilogram of calcium sulfate to H2O to calcium sulfate half H2O is equal to approximately. So you have to calculate that for transformation, what you need. So we know that delta H is, how will you calculate this? Delta H is equal to minus 1575. It is already given this much minus 3 by 2 into 241.8, right? 241.8 plus 2021, or it comes out to be 484.3 kilojoule. How will it come beta? Because per kilogram, na? This delta H comes out to be 83.3 kilojoule per mole of solvent, right? Now per kilogram, what you do, you just the 83.3 multiplied by 1000 and divided by 172. So you'll get this. Okay, so you'll get this thing. So for this, you have to calculate this question. Delta H in the transformation of 1 kg of calcium sulfate to H2O to this. So this will be equal to like. Now same delta S for the transformation. So in the first they are delta and the next they want delta S. So delta S for this reaction is nothing but that is 130.5 already given. 130.5 plus 3 by 2 into 188.6 minus 194. So this is equal to 219.4. Right, 219.4 joule per Kelvin. So this is whatever. Okay, so yeah, we already discussed all the question, right? So we discussed all the question of paper 1 as well as paper 2. So I hope you like this, and I hope your doubt is cleared, right? So these type of questions generally they are asking in their advanced paper. So try to solve this question as much as you can. The more question you start solving, the more confidence you getting, right? And if I have habitual for such type of question, like in the question we are calculating value of p by 10. So you have to calculate p and divided by 10, then they just get the value. So this type of question generally come in your paper, right? To try to solve this type of question. Some easy questions are also there in this question, like this 29th question, 30th question, 31st question, right? So these are some easy questions as well, and some difficult to and questions are also present, like question number 25, so the and question number 24. So these some difficult questions are also present, right? So try to solve the question as much as you can. As you more you are familiar with this, then you are able to solve a question directly, right? So I hope you like the class. In next class we are going to start our new chapter, right? So till just revise the previous concept, and next class we are going to see this as well, right? So let's meet in the next class. Till take care and try to solve question, right?